Chandrayaan 3 is going to be the world's first mission to soft land near the lunar south pole. It would take roughly 42 days for the lander and rover to reach the moon and attempt a soft landing. Last time in 2019, Chandrayaan 2 crash landed on the lunar surface. It was a partial failure and it triggered a very innovative method adopted by the Indian Space Research Organization for the follow-up mission Chandrayaan 3. Chandrayaan 3 is similar to Chandrayaan 2 and yet very different. Chandrayaan 3 lander and rover will attempt to land at the exact same spot attempted by its predecessor in September 2019. But unlike a combination of orbiter, lander and rover, Chandrayaan 3 will have only the lander and rover, but no orbiter. Instead, it will use the orbiter of Chandrayaan 2, which is still operational and has been sending valuable data from its 9 in situ instruments. The propulsion module of the Chandrayaan 3 mission will have just a single instrument named Spectropolarimetry of Habitable Planet Earth, which will analyze the spectrum of Earth to generate data for habitable planets. Another addition to the Chandrayaan 3 mission is the Laser Retroreflector Array or LRA. It is being sent with the lander. LRA would be a passive experiment to understand the dynamics of the moon system. The other 3 payloads being launched with the mission are the same as that of the Vikram lander on Chandrayaan 2.
See, there is certain conditions in which it is supposed to work. And the conditions in which work has a window. If anything happens beyond the window, it may work, it may not work. So what we did this time is the window is expanded. Its ability to land at a higher speeds. Its ability to work within this much quantity of propellant is enhanced. We say this much is the power capability, we expanded.
How about rovers?
Rover, we have not made any change this time. It is exactly the same rover.
To achieve its objectives, Chandrayaan 3 has lander hazard detection and avoidance cameras that will be used to coordinate with the orbiter and the mission control as the lander makes its descent approach to the surface of the moon. Chandrayaan 2 has just one such camera. Chandrayaan 3 has been fitted with 2 such cameras.
So we addressed all such failure modes and we built more rigorous hardening of many systems, including its ability to land at a higher speed, more propellant to handle, more power generation capability, more disorientation capability, more ability to handle rotations. And we added additional sensors and sensor failures we addressed. So, and we did all these test in simulation modes and made sure that all our thinking process algorithms do work under extreme conditions.
All previous spacecraft to have landed on the moon have landed in the equatorial region. Whether it's US or Russia, they all landed a few degrees latitude north or south of the lunar equator. The furthest that any spacecraft has gone from the equator was Surveyor 7, launched by NASA, which made a moon landing way back on January 10, 1968. This spacecraft landed near 40 degrees south latitude. A successful Chandrayaan 3 will not only elevate India into the elite group of lunar explorers as the 4th country to do so, but it would also mark India's expertise to do so at the most tough circumstances and in virgin lunar territory.
If you like the video, do like, comment, share and subscribe.